Greetings, our honorable audience and judge. Today, my name is Guanti Ming and my teammate's name is Nguyen Phung Thao. We are from Vinh School and from Vietnam. Today, we are here to showcase our study on Stingless bee propolis that was extracted from Hoa Binh, Vietnam. Firstly, I'd like to give you a brief introduction of our research topic and the reasons why we chose Stingless bee propolis as our main subject of study. Before I can go any further, I'd like to explain what bee propolis is and what stingless bees are. Now, propolis is basically a very valuable substance that is made by stingless bees in Vietnam, as well as many other countries. And propolis is made by using plant resin and also beeswax. And in the nature, stingless bees use their propolis to seal up many crevices within their beehive, and also to prevent diseases. For this reason, stingless bee propolis has been known for its many health properties in traditional medicine, and because of this, we have chose to study stingless bee propolis. And we also think that this topic has not been studied enough. Therefore, we are going to study it and maybe apply it for many pharmaceutical reasons. Also, stingless bees are bees which do not have a stinger, meaning that they, as the name suggests, stingless bees cannot sting humans or any other creature. They can only maybe bite and annoy us. And the difference from these bees, from honeybees, is that stingless bees produce way more propolis. And they also have a very large variety of stingless bees, especially in Vietnam. And most of these species of stingless bees have not been well researched. So that is also one of the other reasons why we chose stingless bee propolis as our main subject of study. Moving on from our introduction is our main objective. Now, as you can see here, we have two main aims for this project, which will help lead us and help keep us on track. The first aim is to isolate and identify 3 to 5 chemical compounds within the stingless bee propolis. And our second aim here is to evaluate the antimicrobial properties of the stingless bee propolis, meaning that we have to judge how potent and effective those compounds are against bacteria and fungus. Moving on is, as you can see here, is our methodology and scientific work. Now, this means that I will show you the 4 steps that we use in order to achieve our main 2 goals. Firstly, after collecting our sample of stingless bee propolis from Hoa Binh, Vietnam, we had to extract it using a solution of 70% ethanol, and we also partitioned it later with N-hexane and with ethyl acetate. Our second step was to isolate the chemical substances within the stingless bee propolis, meaning that we have to isolate and separate those chemical compounds, 3 to 5 of them, from the extract that we had done in the previous step. And we did this using combined chromatographic methods, containing column chromatography, as you can see in this picture here, and also thin layer chromatography to identify the purity of the substances, and to also, when we use column chromatography, is to isolate those specific chemical compounds from the bee propolis. Our first step was to elucidate the chemical structure of the stingless bee propolis. And by this, I mean that we have to identify what these chemical substances are by looking into their structure. And we did this by using spectroscopic methods like mass spectrum and nuclear magnetic resonance spectra. Now, after our second step, we successfully isolated 5 chemical compounds from the stingless bee propolis. But unfortunately, one of those compounds did not have enough concentration, which is the reason why we only identified the chemical structure of 4 compounds within the sample that we took. And those 4 compounds were alpha-mangostin, cycloartenol, manganoferroic acid, and also cochinchinan. Our fourth step, after identifying these chemical compounds, was to evaluate their antimicrobial activity, which meant that we needed to judge how potent and effective they were against microbes, such as bacteria and fungus, including gram-positive and gram-negative bacteria. We did this by using a dilution method with bacteria and fungus. And now, I'd like to move on to the results that we have collected throughout our study. As you can see from this table here, we have tested all of our 4 chemical compounds on different strains of bacteria free strains of gram-positive bacteria and free strains of gram-negative bacteria, as well as on one strain of fungus. And from the results table, we used the measuring values of MIC50 and also of IC50. MIC50 is the minimum inhibitory concentration, which meant that it is the least amount of substance required to inhibit the growth of visible bacteria. And IC50 is inhibitory concentration, which is similar but not exactly, because it also means the least amount of substance required to inhibit the growth of half of the bacteria or microbe. Now, from these results, you can see that the lower the values are, the more potent that substance is against bacteria or fungus. And as you can see, propolis overall, the whole propolis extract is very effective against gram-positive bacteria, but the B propolis had little to no effect on gram-negative bacteria as well as on fungi. However, out of all four chemical compounds that we found, the most effective and most potent is alpha mangostin, which have the best overall potency and effectivity against both gram-positive bacteria, gram-negative bacteria, and also fungus. Because as you can see on this table here, the values for alpha mangostin, which is the fourth compound that we found, is very low, which meant that it has a very high potency, because not a lot of it is required to kill off and inhibit the growth of bacteria. Now, I'll talk about our conclusion and also our future aims with this project and where it'll go. Firstly, are the direct conclusion that we have concluded from this project. And I would like to say that we have identified successfully 4 chemical compounds within the Stingless meat propolis that was found in Hòa Bình, Hanoi. And we also concluded that the Stingless meat propolis has very good antimicrobial activity properties, and especially the compound named alpha mangostin, which makes it suitable to be a pharmaceutical product and has great potential in that area. Also, we've set up a lot of our future applications, as you can see, and we have thought about it, and we have thought that Stingless meat propolis can be used as an alternative source of healthcare products, especially in Vietnam, because of its antimicrobial activity that we have researched. And also, alpha mangostin can be used, and it can be used for many other healthcare products, such as antiseptics or antibiotics. And if we do more research on this in the foreseeable future, we will be able to further advance our research and also learn more about the pharmaceutical potential, and maybe even develop a sort of medicine or a sort of pill that can help people treat diseases with these compounds and with Stingless meat propolis, which will help develop the lives of many farmers in Vietnam. In conclusion, our project has successfully achieved both of our main aims, and thank you for your listening. If you have any questions, please ask me right now.